Yeah, so we're done with that one. Let's look at combination sum and see what that's all about. So lead code number 39, combination sum. Given an array of distinct integers, candidates, and a target integer target, return a list of all unique combination of candidates where the chosen numbers sum to target. You may return the combinations in any order. The same number may be chosen from candidates unlimited number of times. Two combinations are unique if the frequency of at least one of the chosen numbers is different. Test cases are generated such that the number of unique combinations that sum up to target is less than 150 for the given input. Okay, and we have 3 test cases. All right, let's dig right in. Yeah, so we just finished that one. So this is number 39. Let's do our usual preamble here. Delete lib 0039 combination sum. Okay, right, and then we just do that. We do that. We do that. And then we paste this. Copy. Paste. Oh, right, and then we have to say pub struct solution. And we'll just say vec new just to get things going. Okay. And then we just add these as our test cases. Example 1. We have 2, 3, 6, and 7 with a target of 7. Okay. So test mod, test ex1, and we're expecting output of 2, 2, 3, and 7. Ooh, right. I guess what we can do is just ensure that we're always... I do have code that will actually check vector arrays, but if we just output and make sure we just output in the same kind of order, then we should be okay, right? I can just say vecbang 2, 2, 3, and vecbang 7 for our answers, and then we can just, for actual, we say solution combination sum, and our candidates are 2, 3, 6, 7, and the target is 7. So that should fail. Yep, here. Okay. All right, so how do we want to approach this? Actually, we can throw in the other 2 test cases just to make sure. Well, let's get one working. So we're going to do basically if we make a struct which will allow us to generate combinations like we did for, we did this for AOC. I don't know if you look back at AOC lib source, and it's probably combinations. Yeah. Although this is going to be slightly different, right? Because this is a combination, single combination of everything that we did for adjective code. And now we have to be able to say multiple combinations. All right, so this might take a little bit of time to implement. But if I create like something similar, where we have this, how about this struct combinator, right? And in the struct, we'll keep track of what we have, what we need. And this we can implement an iterator for it. And then, so we have a candidates array. We have this 2, 3, 6, 7. So we start off with 0, 0, 0, 0, and then work our way up with 1, 0, 0, 0, 2, 0, 0, 0, 3, 0, 0, 0, until we have the target number. And if we go past the target number, then we know we reset this counter to 0 and increment this counter. And then so on, right? So if we have 2 2s and a 3, that's a 7. Once we hit 3 2s and a 3, then we reset the 2 counter to 0 and increment the 3 counter to 1. from 1 to 2, right? So I don't know how I can this is what I'm thinking, right? So we have a 2, a 3, a 6, a 7. And if we have 0 of those, 0 of those, 0 of those, 0 of those, that's less than the target, right? And the target is 7. So then we increment this guy, right? And that's still less than the target, right? Because it's 1, 2 is less than the target. We have 2 2s, less than target. And then 3 2s. Right? 2 times 3 is 6. It's still less than the target. So now we go to 4 2s. That's greater than the target, so we reset. Carry. Let's call it a carry case, because we're going to reset this to 0 and then carry here. So this is 1 3, so it's less than target. So we go like this. Oops, that's a 1 now, from now on. 1 2 and 1 3 is less than target. 2 2s and a 3, well, that just happens to be equal to target. So we return, we yield. There's no yield in Rust, but we'll do that. Yield result of 2 2 3. And then we keep going, right? Now, since that's equal to the target, we'll reset, or we'll re-increment. And that's less than the target. And then 1 and 2, right? And that's greater than the target. So now that this is greater than the target, we have to reset this, and we have to this is greater than the target, so we reset that and carry here, 6, which is less than the target. All right, so that's what we're going to implement. And what I'd like to do is implement it as an iterator, because that might come in handy in future lead code problems, or even future advent of code problems. We can just steal this code and implement an iterator. So we have the nums, which is this array, the array we're given, right? We have the target, oops, which is just an I32. And then what we'll need is this multiplier array. So we'll need one for every index in nums. Okay. So we're going to impl iterator for combinator. Before we do that, let's create a new, just to make it easy. Here's what I'd like to do up here. Combination sum is just say, right, let C equals combinator new candidates dot sort. Okay, let's sort them. Maybe we could sort them in the new function. Maybe that makes sense. Candidates, comma, target, right? And we can just pass it by reference here. We don't need to pass the vector in, and then just say c.collect. And that would be the simplest way to do it with an iterator. So let's create a new function for this guy. Yeah, impl combinator, fn new. We'll take in the candidates as a vec I32. I think Clippy will yell at me if I say reference to a vec of I32 and then target I32. And then I'll say let mut nums is candidates clone nums.sort. And then, oops, and then we just return, oh, this returns self of nums, comma, target, comma, mult, which is going to be a vec, vec bang semi, 0 semi nums.len. That way it starts off all at 0. It doesn't like this. What did I do wrong here? This seems fine. Oh, because I called it multi instead of mult. Okay. And then if I try to build this, it'll complain that we haven't implemented the next. Right, we have these two things we need to implement. And the type is just going to be a vec of I32, right? That's what we're returning. We're yielding this result here of arrays. So that's what the type is going to be. And then expected a vec. Oh, yeah. Can I say to vec? And now it doesn't like oh, it doesn't implement len? Move occurs because num has vec type 32, which does not implement something. All right, let's take a look at the actual error. Does not implement the copy trait. Can I do it the other way around? To vec clone? Still doesn't like it. Value borrowed here after move. Oh, because I'm moving the, okay, so let len equals nums len. I could do that. There. We just have to save off the length before sticking in here. Okay, yeah, and then we're not using these guys. All right, no worries. So now we just have to work. Oh, what did I just do? Go back. Okay, so we need to work out the iterator. Let's say we have a step function which increments each value, right? Basically, the step function figures out the next values for the mult array. So let's make that up here. Fn step mut self. And it doesn't return anything. What we can do is start out, say which index we're working on. Start off at 0. While idx is less than self nums len. We're just going to increment along until we are less than, or yeah, we just increment the index we're on, and then if it's less than, if it's equal to the target, we can return it. Oh, we can just return it regardless, right? And then we can just check down here the next and keep stepping until we find the next one. Yeah, that'll work. So we can just say self mult idx plus equals 1. If self dot mult, right, now we need to calculate the value. Let's do that. Fn value of self and return I32. So with the current set of indices, what's the value that we're going to get? And that should be, we should be able to do this with composition, right? Self nums iter, zip with self mult iter, right? We're just multiplying the two of them together. So we just map, zip gives us a tuple, right? Yeah. So we can actually deconstruct it, right? We can say A and B, and those are references. So we can say star A times star B. That's a little awkward. And then just sum them up. And since it's returning I32, hopefully it'll be able to figure out that that sum is supposed to be an I32. So we can say self value is less than or equal to the target. Return. And when do we need to be able to increment the index. So the next thing we're going to do is we're going to say, okay, we're greater than the target. So we say self mult of the current index gets reset to 0, and we move the index to the next one along. Okay, yeah, and then if we run out, right, we've hit the end of our list, we're done. Maybe we should return something. Maybe we should return a bool saying whether or not that worked, and then this is false, right? And that way we can call step, and if step returns false, then we know we can return none from next. right? And so now what this will do is it'll set fn combination test. And what I can do is say let C equals combinator, that's hard, of, oh, do I do this? I can just 2, 3, 5, 7 with the target of 7, right? This is this test here, but I just wanted to see, I wanted to see each step, right? So I can say assert. Oh, I do need to make this mutable. Assert C step. So we took one step, and then we can say assert EQ. The first one should be 2, 1, 0, 0, right? So 2, 1, 0, 0 is equal to C dot mult. Will that work? Let's find out. Didn't like that because I typoed there. Oh, and I forgot to put the word test. Didn't like this. Oh, self-target. There we go. Combinator is not an iterator. That's correct. So we're going to just do a vec new here, just to get it to build. Okay, and our test is expected. Oh, we do it. I'm passing in a reference. Okay. And what else? Assert EQ. No implementation for integer 4 is equal to vec. Okay, so let's make this a vec. Vec bang. Like that. Oh, right. So we're gonna say, yeah. We're gonna do 1, 1, 0 for each. Yeah. So we're gonna do each step along here. Should I assert each one of those? Let's find out. Let's find out if this works. 2RY. So it should be while we're less than or equal to target. 3. Right, 3 times 2 is 6, 4 times 2 is 8, so it shouldn't come up with that one, but it should come up with this one, and then it should come up with this one, right? Right, this test is still failing, because we haven't written it yet. Okay. A lot of entries. But it seems like the step is working because it was able to at least get to this point here. All right, that makes me happy. Let's put this test back in. And then we'll write the iterator now. And this is the way the iterator is going to go. We're going to just say while, well, we're going to say if not self step, if we couldn't step forward because we got too high or we went past our index, then we return none. So that was easy. That's the none case. Now what's the real case? While self.value is not equal to self.target, we wanted to do a self step. Do I want to put a limit in here? Because I could see this doing an infinite loop here. We also need to check the return value. If self-step, if not self-step, return none, right? And once it is equal to target, then we're going to say return some value. No, we're going to return the number of numbers for each one of the entries in the mult. I guess the most straightforward way to do that, right, would be just say let mult result equals vec new for index val in self mult iter enumerate right? And then we can just say for underscore in 0 to val, result push, self num, idx. Right, and that all this will do is do val entries of this number into the index, and then we just return it result. I think I can clean this up with a little composition, but this might be all we need to do. Right. The only thing I want to do is maybe there might be an infinite loop here. Let me just loop limit equals, I don't know, 1,000. Loop limit minus equals 1 if loop limit equals 0. Panic. Possible infinite loop detected. All right. That's a little sloppy, but it does the job. Star val for that, and then some result, right? All right, that passes the test. Let's put in the other two examples. Right, test ex2. We're going to assert that this is equal to this value here. Copy, paste, effect bang. And the actual is going to be solution combination sum, effect bang, 235, comma 8. Right, and does that test pass? I'm going to close this to get a little more screen real estate, and that way I can do this and I can see right here if it passes. And then our last test, ex3, we're expecting a effect bang. Oh, I don't know if it'll let me do that. I've always had issues with that. I can just say assert, solution combination sum, effect bang 2, 1 is empty. Right? I can do that. And that passes. Okay, so I think we have code. Let me get rid of the comment. And then copy paste everything. Can I get the, I can't get the whole thing on. Okay. We'll do this bit. Paste. Oops. Paste. Then we'll do this bit. Paste. And then we'll do the iterator. Paste. All right, and submit. You know, what do you know? Accepted. Quick question: how satisfied are you with our new design? I have no opinion. All right, so we got decent runtime. Beats 56%, and decent usage of memory. All right, I can live with that solution. Let's check in with Clippy and then commit the changes. Ooh, what do we need? 30. We don't need to clone. I'm online 30. What happened? Oh, I gotta save it first. There we go. 18, because I deleted that giant comment. Okay, so we don't need to clone this. We could just say 2vec, and that automatically clones it, I guess. Yeah, nice. I like that. Is there anything else? Oh, right. I was going to see, is there a way we can clean this up? There's a repeat, isn't there? A repeat iterator? A Rust repeat iterator. Repeat in standard iterator. So I should be able to say repeat LT, creates a new iterator that endlessly repeats a single element, and then take. Right, this says repeat for, and then I say take whatever, right? So the val is how many we want to repeat. So I can just say result.extend iter repeat val self nums idx take val. Will that work? Oh, I need to import it? Yeah, import standard iter. Arguments to this expected use size found I32. Okay, as use size. Yeah, and that passes Clippy. It passes the test. Should we try it over here? Let's just grab this one line. There it is. I go back over there, and where did I do it? Here. So paste that in there. Oh, yeah, I need to import the standard iter. I forgot that line. Nice. Okay, so that works too. Some reason it's using more memory. And then we should be able to get rid of this for loop as well. Right? We should be able to say self mut iter enumerate map idx val. Can I do that? Into this. And then this gets a sum. It doesn't like something. Oh, that closes the send. That closes the map. Oh, so extend it goes like that. Okay. That closes the map and that closes the sum. Yeah. Well, that, no. Oh. Oh, right. So, that's going to generate, yeah, if I do this way, it'll generate separate I do this, right? And now what's the output of this? Let's do it this way. I'll just put a vec new here because I want to mess around with this. So I can say let x equals that, and that's going to be a map of what? Something. And if I say collect on that, that's not going to collect what I think it's going to collect, right? Vec take repeat I32. Println x. What I'm thinking is there's a way to maybe flatten it. Nope. Yeah, so this is returning a take iter repeat element, blah, 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 blah. Maybe I collect here. I should be able to infer, right? Yeah. Two, 2, 3, and 7. 2, 3, 3, and 3, 5. Were those the 2, 3, 3, and 3, 5? Yeah, yeah. So now we have to somehow just collapse these down into individual arrays. Because each one of these is an answer. maybe I'm trying to get too fancy, because it's already unintelligible, and we have to make it worse. So I think I think if we just go back to the way it was with the single repeat in there, I think that would be the, yeah. Oops. There's still more to undo here. Oh, you have to get rid of the map. That's right. There. Okay. Yeah, we'll leave it like that, because getting any further into functional programming is just going to make it messier and messier to read. It's one of the things where you can, when you're writing it, you know what you're doing, so you write it, and then when you come back a month later and you look at it, you have to untangle everything. Like, it's like a regular expression in that kind of sense. All right, I think we're good. Git add source, git commit -m problem 39 combination sum. Nice. Clippy's still happy. Good. So let's go back here now. We can tick that box. Check that circle. All right.